All right, so our last lesson in chapter 9 is geometric power series. So we have some special things that we know about geometric series, like we know that the sum from n equals 0 to infinity of a times r to the n can be expanded into a plus a times r plus a times r squared, so on and so forth, and that we can actually, there's a calculation to give us the sum of that value, and what it is a over 1 minus r. So this is the actual calculation for the value of the sum of a geometric series. Okay, so if we're looking at the equation 1 over 1 minus x, we could expand that knowing that the terms will be, so basically we can expand that knowing that the top number is a, and then the minus x is basically our r value. So when I plug this into the sum, I get a is 1 and r is x to the n. So this series would expand out as 1 plus x squared because we're having a constant multiplier of x. So let's, one thing that we know about geometric series is that the endpoints are divergent. So meaning that when r is equal to 1, the series diverges. So we don't actually have to check the endpoints. That's super nice. Okay. So find a power series and the interval of convergence for each function. So looking at the function 1 over 1 minus r, I need to pick, centered around c is equal to 0, I need to pick out my a value and my r value. So first I'm going to look at the equation, and like the numerator tells me my a value, and I can rewrite this as 1 minus 1 over 1 minus x. So that means the x value is going to be this 2x, or the r value is going to be 2x. So I'm just going to spell out a is equal to 1 and r is equal to 2x. So as the series, I'd write the sum from n is equal to 0 to infinity of a times r to the n. So I get the sum from n is equal to 0 to infinity of 1 times 2x to the n. This is my series, okay? And the interval of convergence, I'd be able to figure out by taking my r value. We know that for a geometric series that in order to divert or to converge, sorry, that r has to be less than, the absolute value of r has to be less than 1. Okay, so we know that the absolute value of r has to be less than 1, and in our case, 2x is the equation for our r value. So I get 2x has to be less than 1, and so I'm going to drop my absolute values to give me -1 is less than 2x, which is less than 1. Divide everything by 2, giving me -1/2 is less than x is less than 1/2. And we don't have to check endpoints. To check the endpoints, because when r, the absolute value of r is equal to 1, the series diverges. So our interval of convergence would be -1/2 to 1/2. All right, let's look at the next one. So I have another function. We have f of x is equal to 1 over 4 plus x, and we're going to center around c is equal to 2. So this time the series is a little bit different because what I need to do is get a 1 right here. Because remember, we want our geometric series to be written in the form 1 over 1 minus x. So I need this to look like 1 over 1 minus x. So I have a little problem. what I'm going to do is I have two problems. One, I need a 1 where that 4 is. And two, I need my function to be centered around 2. So I am going to have an x minus 2 here because we're centering around as x is equal to 2. So because if I subtract 2 in the denominator, then I'm going to add 2 back in the denominator. So I'll just put, okay. So I end up with f of x. Another way written is 1 over 6 plus x minus 2. Okay, I can now see that centering around x equals, or c is equal to 2. But I still need that 1 in the denominator, so I am going to divide the numerator and the denominator by 6. So I have f of x is equal to 1/6 over 1 plus 1/6 times x minus 2. Okay, so I guess what we should say here is that instead of 1 over 1 minus x, it needs to be a over 1 minus x. Okay, a over 1 minus x. So now we can pick out all of our pieces. So the a is equal to 1/6. Okay, and my r value comes from the denominator. It's going to be right here. It's 1/6 times x minus 2. But remember from the equation that there's a negative sign in front of the x, which means that this is actually going to be negative 1/6, because I could rewrite the denominator as 1 minus negative 1/6 times x minus 2. Okay. All right, so let's go ahead and write my series. My series is from n is equal to 0 to the sum from n equals 0 to infinity of a, which is 1/6, times negative 1/6 times x minus 2, okay, to the n power. So right here, this is my r, and this is my a. Okay, so let's clean this up a little bit. I have the sum from n is equal to 0 to infinity of negative 1 because of the negative inside the parentheses. So negative 1 to the n, okay, times x minus 2 to the n. So I'm just going to apply the n to the outside of the parentheses and then to that. And then we need to give the n to the 6 inside the parentheses. Okay, so in the denominator, I have 6 to the n times 6 to the n from inside the parentheses, and then the 6 on the outside, so times 6. And then we can clean that up just a little bit more. I have negative 1 to the n times x minus 2 to the n over 6 to the n plus 1. Because the bases are being multiplied, we can add the exponents. All right, so this is the sum. This is one way to write the sum. Yes, there's lots of ways. But now let's get our interval of convergence. So we need to take our r. The absolute value of r has to be less than 1. So I have the absolute value of negative 1 over 6 times x minus 2 has to be less than 1. So negative 1 is less than, I'm going to write x minus 2 over 6 has to be less than 1. So it multiplies by 6, giving me negative 6 is less than x minus 2, which is less than 6. Now add 2. So I have negative 4 is less than x, which is less than 8. So the interval of convergence would be negative 4 to 8. And again, we do not have, this is a geometric series, so I don't have to test the endpoints because I know when r is equal to 1, the series diverges. All right, let's go on to the next one. We have the equation 3 over 3 minus 2x, and we need to center around c is equal to 1. So let's go ahead and start off by getting our centering. So 3 minus 2 times x minus 1. Because remember, we're centered around 1, so our x is going to be off by 1. And then I can see now that I need to, when I do this, okay, what I get here is negative 2x plus 2. So what I've done is actually added, that looks horrible. Okay, what I've done is actually added 2 to the denominator. So I'm going to subtract 2 from 3. So this, when I distribute the negative 2, I subtracted 2 in the denominator, which means I also need, I'm sorry, I added 2 inside the parentheses, which means that I need to subtract 2 to keep my equation balanced. So f of x is equal to 3 over 1 minus 2 times x minus 1, okay? Which is perfect because I also needed a 1 right here, okay? So I can see that the numerator gives me my a value. So my a is equal to 3, and my r is equal to 2 times x minus 1, or if you want to write that as 2x minus 2, you are more than welcome. Okay, so I can write my series since I know my a and my r value. From n is the sum from n is equal to 0 to infinity of a, which is 3, times 2 times x minus 1 to the n power. Okay. If you want, you can write it as the sum from n is equal to 0 to infinity of 3 times 2x minus 2 to the n power. Also legal. All right, let's get our interval of convergence. So since r is equal to, I'm just going to leave it, the absolute value of r has to be less than 1. So my r is 2 times x minus 1, or if you distributed, then that's fine too. Let's split our absolute value. So negative 1 has to be less than 2 times x minus 1, which is less than 1. All right, first things first, we're going to divide everything by 2. So I get negative 1/2 is less than x minus 1, which is less than 1/2. Now let's add 1, giving me, okay, giving me positive 1/2 is less than x, which is less than 3/2. Yes, okay. The interval of convergence then, again, endpoints don't have to be tested in a geometric series, which is super nice. So I get 1/2 to 3/2, endpoints excluded. All right, almost there. Let's do 2 more. We're going to find the power series representation for the following function. So I have 1 over 1 minus x quantity squared. Okay, so you may think you want to expand out the bottom. So 1 over 1 minus 2x plus x squared. And then I'm like, oh, that doesn't really look like the geometric power series with my r and my a present because I have this middle term here. So a little trick is using manipulations to help us evaluate. So I know that 1 over 1 minus x squared is equal to d dx, or the derivative of 1 over 1 minus x. And you're like, wait a second, really? Okay, let me show you. So the derivative of 1 minus x would be d dx of 1 minus x to the negative 1. Let's go ahead and take the derivative. So I get negative 1. Chain rule says I leave the inside. I decrease the power, so to the negative 2, and then I multiply by the chain, so times negative 1, which gives me positive 1 times 1 minus x to the negative 2, which is 1 over 1 minus x squared. Look at that. So these are equivalent right here. Yeah? Okay, so I know that 1 over 1 minus x can be written as a series as, okay, my a is equal to 1 and my r is equal to x. My a is the numerator and then the x comes from the 1 minus, after the 1 minus. Okay, so the sum from n is equal to 0 to infinity of 1 times x to the n would be this geometric series. I have an interval of convergence. The absolute value of r has to be less than 1, so the absolute value of x has to be less than 1. So -1 is less than x, which is less than 1, or -1 to 1 is my interval of convergence. So just for funsies. Okay, so the power series of 1 over 1 minus x is the sum from n equals 0 to infinity of 1 times x to the n power. Okay, but that's not what we want. What we want is 1 over 1 minus x quantity squared. Okay, remember that is d dx of 1 over 1 minus x. And then you're like, okay, yeah, so that 1 minus 1 over x can be rewritten as the sum from n equals 0 to infinity of 1 times x to the n. Okay, so 1 over 1 minus x quantity squared is equal to the derivative of the sum of from terms n equals 0 to infinity of 1 times x to the n. So now we just need to take the derivative of this sum. So I get 1 over 1 minus x squared is equal to, when we take the derivative, we take it with respect to x. So I need to take the derivative of x to the n. So I get the sum from n is equal to 0 to infinity of n times x to the n minus 1. And then our interval of convergence, remember when you take the derivative of a series, the interval of convergence, the bounds stay the same, so -1 to 1, and then any parenthesis when we take a derivative stays a parenthesis, so I'm just going to go ahead and leave those. We have the same interval of convergence here. Okay, so that is our series written. We basically used a geometric power series and manipulated it to write the sum of our equation here, or the value of our equation. Right, so let's go ahead and do one more. I have f of x is equal to the arctan of x. Remember way back, we know that the arctan of x is equal to the integral of 1 over 1 plus x squared dx. Oh, you remember that? Okay, so 1 over 1 plus x squared can be rewritten as a series of the sum from n equals 0 to infinity of the a is equal to 1 and the r is equal to negative x squared, which I get from right there. All right, so I write this as 1 times negative x squared to the n power. Rewrite this in a little bit different way. The sum from n equals 0 to infinity of, let's pull out this -1 right here. So I have -1 to the n times x to the 2n. Multiply my exponents together. Okay. Okay, so now we can take the arctan of x is equal to the integral from 1 over 1 plus x squared dx. Where I was like, wait a second, arctan can be written as a sum. The integral of the sum of n is equal to 0 to infinity of -1 to the n times x to the 2n dx. We're taking the integral with respect to x, so we have arctan of x is equal to, all right, so I have the sum from n is equal to 0 to infinity of the 1 to the n is just a constant, so I have negative 1 to the n times x to the 2n plus 1, because you're adding where our power is increasing, divided by the power, so 2n plus 1, okay? And then remember, since this is an indefinite integral, we have to add our constant of integration. All right, so we have the arctan. Oh, just for fun, this is your answer right here. Okay, just for funsies. This series would be expanded as C plus, okay, I'm going to plug in 0 for n. So negative 1 to the 0 is 1. 2, or sorry, x to the 0 plus 1 is x over 1 minus x cubed over 3 plus, I'm going to plug in 1, 2, 3. 3 to the n plus, well, sorry, plug in 2. So negative 1 squared is positive, and then 2 times 2 plus 1 is 5. So x to the 5th over 5 plus dot, dot, dot. Okay, so this is what arctangent of x expands out to. All right. Oh, one last thing. We have our interval of convergence. Okay, so our r is, well, let's go back to here. Okay, so my r, the absolute value of r has to be less than 1. So we have the absolute value of x squared has to be less than 1. So x squared has to be less than 1 but greater than negative 1. So basically, negative 1, x has to be between negative 1 and 1. Okay? All right, so from negative 1 to 1. All right, that is it for today.